Hey everyone, today I'm going to be showing you my simple setup that uses GPT Vision 4 to take in visual data and provides me textual descriptions of that information and Langchain to create a RAG chatbot over that data that I embed into a Chroma vector store. But first, I want to just give some thoughts on multimodal and where I think it's going. I think that in 2024, we're going to see a bigger and bigger trend of multimodal models being used and leveraged as they become more robust, they become more reliable. And I think that is super exciting because now it just opens a whole other window of opportunity for us to get information from. It's not just text anymore, it's also images and possibly videos if you take out the frames and such like that. So yeah, I think it's just a very exciting time, and that's why I'm making the video, because I'm currently exploring GPT Vision 4 for other use cases, such as the Painpoint AI app that I am currently still working on and talked about in a previous video. And so with that being said, let me just show you the demo of what I did here, and then I'll go in the code, and then we'll call it a day. Okay guys, I got a quick demo video here for you. I just recorded it real quick before I recorded this video because it's just easier to show you the condensed version, because it did take a while to send all of the images of the PDF to GPT Vision and then load them into Chroma Store. So I just thought it'd be easier to show you the process start to finish, super nice and clean. So you can see I'm uploading the Datadog pitch deck, which I think I got from, shout out Langchain's GitHub. Y'all got some nice practice PDFs to use for this purpose. And then right here you can see that I have it printing out the entire description that GPT Vision gave. And so it's kind of collecting all of the descriptions of each run. So every time we send one image, it's describing that slide, returning the description, and then we're adding all of those descriptions into one text file, and then we're just writing it out here. And that entire text file is loaded into a Chroma DB store, which holds the information that we need. So as you can see, I'm asking it questions like, what was the revenue of Datadog according to the year GAAP, which is like, I guess like the formal financial modeling or report that you need. And I believe it got this one correct. So I double check it after it answers the question, which you should always do in testing, obviously, just to make sure that it's not spewing out nonsense, acting a fool. And we're asking the question, and boom. So we have $2.01 billion. So I am now just coming over with this to pull it over and show you, I think it's like slide 12 or 13 or something. Here we go, double check, and nope, keep going, boom, right there. Cool, so quick demo right there. So with that being said, let's hop over to the code and I'll show you how I set this up. Okay, first I'm going to go over the app file where we have the Streamlit App interface, kind of go through what we just did, and then I will take you into each function and we'll talk about what it's doing. So first we're just setting up, some state variables, some session state variables, and then we have the uploaded file that they can add, and then once that's uploaded and we hit enter, we go to save pitch deck images. So this is the first function. All right, so the first thing I want to make note of is the two directories here, uploads directory and the descriptions directory. These are local directories, so this is only going to work on your local computer. I think that's perfectly fine if you're just trying to have a simple interface for documents on your laptop anyways. I think it works perfectly fine. And so deck descriptions are going to hold the TXT files of the combined descriptions of each GPT Vision call for each image. So as you can see here, it has the entire text file that we loaded into the Chroma DB store later on. And you can also see that I have some things that say, I'm sorry, but I cannot assist this request. I do think that there were some error messages. Sometimes when I was calling OpenAI, it would say, hey, like this file is too large, it's not the right format, which I'm not totally sure why, to be honest, because those files, one image should not be over 20 megabytes in my opinion. If it is, maybe I'm just messing up there, but I just kind of bypassed that by doing some error handling in the analysis function that is making the calls to GPT so we don't break the app, and then it can continue on. So on the whole, it will get enough of the description of the documents, in my opinion. And then I think maybe to improve this, we could just clean the data by saying every time it says, "I'm sorry, but I cannot assist," or something like that, where it's like apologizing, we just don't add that to the description text file before adding it to the Chroma store. But anyways, let's go back. And so what we're doing here is we're saving this pitch deck file to a local directory called local uploads, and we are getting images for each page of the PDF by calling convert from path and sending in the temporary PDF path that we create. And this function is from PDF to image Python package. Once we do that, we get all of the images, and then we iterate over each of them, and then we are going to save them as a singular image inside of the directory. So you will get something that looks like this, and then we return all of the image paths in an array. Once we do that, we are going to then say analyze pitch deck, and we're going to pass in the parent directory of the image paths. So we're passing in the parent directory here, so it'll be local uploads / ddogq3 yada yada, and that is calling this function right here, and that is going to be calling generate description no batch. So I do have batch and no batch. I think I was messing around with different types, like batching 5 images at a time for each GPT vision call, but I think it made it less descriptive of the individual image, and I wanted to get as much detail as possible for each slide, so I just made a call for each slide. It's honestly not that much, to be honest. You're not going to be calling this a bajillion times. You know, this was a significantly larger deck than I assume like investor decks are. Like if you're pitching someone, it's probably only like 5 slides or something. So I really wouldn't get too bent out of shape about it. But what we're doing in this function is we are iterating over all of the images, all of the image paths, and we're going to encode each of the images as a base64 JPEG image, and we're going to be creating a prompt message where we have the user with the content, and we have type text, please provide the detailed description of slide index +1, and then we're going to pass in the image URL as well. And I added detail hide just because I forgot to mention, actually, when we are saving the images, I had to resize the images to 512 by 512 because those were one of the only formats that OpenAI's API accepts, and the original dimensions of the slide decks were, I think, like 2000 by 4000 or something crazy. So that is something I just want to make note of as well. So the quality does reduce a bit, and that's why I wanted to keep a high detail, because I think the reduction in quality already would have made it hard or somewhat difficult for the vision model to understand what was going on. Next, we call the client, chat completions create, model GPT vision preview, messages prompt message, max tokens 300. And then we are getting the description for that image, and then we're appending it to the array of alt descriptions that we instantiated up here. Once we do that, I'm also adding a sleep here because, again, I'm iterating through a bunch. I don't want to get rate limited, so I'm just, to be careful, sleeping it for ×5. I don't think you need to worry about performance right now if you're just trying to analyze your own stuff. And then we are going to get the full description by combining all of the descriptions in the array into a single string. And then we're saving that into a final file called description.txt and returning the description as well as the file path that we can get the description from for ingesting that into our Chroma vector store. So then we return the analysis results, and then we get the description file path, and then we pass it into add documents to Chroma. And now here I will talk about where this is coming from in a second, but all you need to know right now is that I am importing my vector store from another file, chain.py, and I am loading the documents from the file path that we get, and then I'm splitting it recursively because it's a single text file, chunking it, kind of kept it small and some overlap just to kind of make sure, you know, there's enough there. And then we add the documents to the vector store that we have. Once we do that, we have the input, and this is where the user can just ask questions, and we have an analyst chain, which comes from the same file that the vector store comes from, and we just simply call analyst chain.invoke user input, and we will get the response. So let's look at that, and then I think that will be good for the video. So here I kind of copied the pattern that I've seen in some of the other RAG templates that Langchain has, and I actually find it pretty nice, just using some Langchain expression language to make it pretty concise. And it's not a lot of line of code, but it's a very powerful setup right here. And so right here we have our template, we create our answer prompt with the chat prompt template from messages, get our model, and then we create our chain. So first we have the context. So the context is going to be coming from the retriever. The question is going to be a runnable pass-through. And so it's going to pass through the answer prompt, and it's going to go to the correct variable right there, question, and then we're going to pass it to the model, and then finally the string output parser, which will give us the output text. And here I'm instantiating my Chroma vector store, so I'm just calling this whatever collection name you want. Then we create a local file here, and then the embeddings functions is going to be OpenAI embeddings. Then I make the retriever, and then I get the chain by calling getRagChain with the retriever sent in, so we can actually use that here. And yeah, then I just import that chain all the way at the top, and then you can simply use analyst chain.invoke because this chain implements the runnable interface, and all runnable interfaces have invoke, a stream, batch, and a batch, and stuff like that. And that is pretty much the setup. I can put this to my GitHub as well for those interested in taking a look and trying to play around with it. I do think it's pretty interesting. I was just kind of, exploring more ways that you could use GPT vision as I'm still doing the Painpoint AI app that was from my last video. And yeah, I came up with this. I think it's pretty interesting, and I hope that you guys find it interesting too. But with that, I will end the video here. There's not much else left to say other than drop a comment, drop a like, hate comments, love comments, whatever comments, I love them all. And don't forget to subscribe, join the Discord, and until next time, much love and peace, y'all.